Good day and welcome back. Going to explain about second case study, which is about the motion of charge caused by electric field. In my last video, we discussed about the production of cathode ray. So now we are going to study the effect of electric field when the electron travel in between the two parallel plates. So for this case study, I'm going to use questions in 2016 past year paper. So this is the questions and the information provided in that paper. So before we discuss further, let us revise something, which is about the electric field strength, electrostatic force, and also the acceleration of electron when it is in the electric field. So first of all is the electric field strength, which is equal to V divided by D. So the potential difference here is a little bit different from what we have discussed. So we can see that the electric potential is 6 volt for upper plates and it is negative 6 volt for the bottom plate. So to calculate the potential difference, what we do is we get the higher potential minus the lower potential, which is 6 minus negative 6. So and then divided by 0.01 meter, and you will get electric field strength as 1,200 watt per meter. Next, for the force, so it is quite straightforward. Multiply Q with E, you would get negative 1.92 multiply 10 to the power of negative 16 Newton. And as for the acceleration, so you can just apply the formula that we have learned. So you will get A is the negative 2.11 multiply 10 to the power of 14 meter per second square. So before we move on, so let us clarify again the direction for each of these variables. So first, the electric field is flowing from the higher potential to the lower potential, which is downward. So for the electrostatic force, since the charge of electron is negative, so the force is outward force. And as for the accelerations, it will follow the direction of force, which is also outwards. So after we got all the information here, so we move on to talk about the motion of the electron in the field between the parallel plates. So for the next discussion, I will do a little bit tuning on the positive or negative sign on E, F, and A for easier discussion. So we will discuss the motion of electron in two components. First is the horizontal component and the vertical components. So horizontally, we know that the electron is moving in constant velocity. There's zero net force act on the electron, so there is zero accelerations. So for constant velocity, the only formula that you can apply is V equal to distance divided by time. So the distance here is referring to the length of the plate, which is 5 centimeter. So from here, we could get the travel time for the electron to move from the left to the right end of the plate, which is 1.25 multiplied 10 to the power of negative 8 seconds. Now we move on to the vertical component. There's zero initial velocity, and we know that there's force causing the electron to accelerate upwards. So here I would use the formula of S equal to UT plus half AT squared. Substitute all the value, you will get that the outward distance is 1.6 centimeter. So graphically, so we're going to look what happened to the electron. So we have the electron with constant velocity and as acceleration outwards. So what we expect from the calculation about the 1.6 centimeter is that the electron would travel at this point in the end. However, this is impossible since the electron will be stopped by the plate at that point. So in real scenario that the electron will be travel up to this point. So now we're going to revise what we have calculated just now. So first, we're going to start it with the vertical component since we know that the limiting factor is in the vertical directions. So electron is stopped by the plate where the outward distance is equal to 0.5 centimeter, which is half of the distance between the two plates. So using the formula of S equal to UT plus half AT squared. So in the end, you would get the time to travel from original point to the plate is 6.88 multiplied 10 to the power of -9 second. So using these informations, now we're going to calculate the horizontal distance using the formula of distance equal to Vt. Substitute all the value. In the end, you will get the distance as 2.75 centimeter. So graphically, the 2.75 centimeter is referring the distance from the lab to the destination of the electron. So next, I'm going to discuss the questions that I would like to add to this case study. So now we're going to suggest how we can improve so that the electron can escape out from the parallel plates. So I give you a few seconds to think of. So the tips that I can give here is that you can think back the parameters that we have considered just now. So the first answer that I would expect from most of the students is we can reduce the length of the plate, which it should be less than 2.75 centimeter. And then you can recall back, we calculate about the vertical distance, which is 1.6 centimeter in the first trial. So we can increase the distance between the plate to more than 1.6 centimeter. And then we can reduce the electric field strength so that the electron won't accelerate too fast by reducing the potential difference between the plates. So lastly, increase the horizontal velocity of electron. Next, I also would like to discuss another questions in the past year of 2019. So I'm still using the same informations. So the question here is about to determine the work done for the electron to emerge at one end of the plate, or you can understand as to escape at one end of the plate. So for this part, I'm going to talk more about the electric potential and the electrical potential energy. So please remember that the electric field strength is constant in the region between the two plates. So we have the formula of V equal to ED. So which you can compare with the formula of Y equal to mx. So the V here is changing linearly along the distance between the plates. So we rotate the figure here. So if we plot the graph of V against the D, so you expect a linear graph that the electric potential is reducing from 6 volt to -6 volt linearly along the distance from the left to the right. To calculate the work done, so what we do is we apply the formula of Q multiply potential difference. So take note that the electron is travel from the electric potential of 0 volts to 6 volts. Substitute the value and you will get the answer of -9.6 multiplied 10 to the -19 joule. So do you have another method? Yes. So another method is we can use the formula of force multiply the change in distance. So the electron is travel from the distance of 0.5 centimeter to 0 centimeter. So substitute the value where the force is calculated previously, and you would get the same answer as -9.6 multiplied 10 to the power of -19 joule. So I have discussed almost all the formula I mentioned in my roadmap video. So you still haven't get used to all the derivations or the formula. So I suggest you can rewatch again or you do some more questions. So I will conclude my discussion today. So if you have any more questions, you can leave it in the comment section and I will see you in my next video. Thank you for watching.